Welcome back, students, to one more session of your organic toolbox. So in the introduction video I have given what actually is a toolbox, organic toolbox. Then I have bifurcated into three categories, isn't it? Carbon-carbon bond formation, carbon X bond formation, and function group interconversion formation. Now let me start off with the mechanisms of different name reactions which come under these categories, right? So in the first mechanism video, let us start off with the most famous, aldol condensation. So basically aldol condensation, what actually it is, what are the different types, what is the mechanism, we will see. Here aldol condensation, basically this is an organic reaction. What happens here? Let us write that. Aldol definition I am writing. So aldol condensation is an organic reaction. Okay, done. Now what information are we going to get in this? Here, in which either an enol or an enolate ion, that is important, most important. We will see what is that also. There, an enol or enolate ion. Okay, enol or the enolate ion reacts with which one it reacts? It reacts with a carbonyl compound. Okay, we will see what is enolate or enol ion also. Reacts with carbonyl compound. Done. After reacting, what it forms? It forms a compound called beta hydroxy aldehyde or beta hydroxy ketone. Okay, now after this is formed, what is the next step? It's going to be followed by a process called dehydration. So once this dehydration is over, when water is removed, it's going to give a compound called conjugated enone. Okay, there are a lot of terms here, isn't it? Right, now let us simplify the terms then. Right, so what is actually, when you are learning your grade 12 CBSE, simple thing, we will write whenever aldol condensation, this is a bit complicated, simplified wise, we say whenever an aldehyde, okay, the functional group is CHO, okay, when two aldehydes combine, right? Yes, so this reaction between aldehyde or means it can be a ketone also, not a problem, right? But you have to remember here, if it is an aldehyde and ketone, it will be cross aldol reaction. Here it is aldehyde, ketone, that's okay. But if it is aldehyde and ketone, if it is, then it becomes cross aldol. So aldehyde and aldehyde, but what is the requirement? It should have alpha hydrogens. So what is alpha hydrogen? Alpha hydrogen is nothing but a hydrogen adjacent to the functional group. If they react in the presence of dilute alkali, okay, I'll show you what is the variety also in this. It reacts with dilute alkali, as I said, it's going to form beta hydroxy. I am generalizing it. Instead of writing aldehyde and ketone, I am writing beta hydroxy carbonyl compound. Okay, beta hydroxy carbonyl compound. What is this beta hydroxy carbonyl? This is nothing but aldol. So this aldol contains both aldehyde group as well as alcoholic group. Both functional groups will be present. Now after this, as I suggest, what am I going to do? I am going to then, during this process, means as I told you, dehydration will happen, water is removed. When you heat, water is removed. This is this process. You will be getting a compound called alpha beta unsaturated compound. Alpha beta unsaturated compound. Okay, we will see what actually are all this also. So but for your grade 12th, you'll remember like this, but when you're going for your competitive exams, you should have a clarity about aldol condensation, students, right? So this is done. Now what, let us go with this once again. So for 12th class, you can remember this and go right in the exam, right? But here when it comes to this particular thing, remember here, as I told you, aldol condensation process, it can be either reaction which enol, you can have enol mode as well as enolate mode also, right? So let me write the things. Here you can have what mode? Enol mode. One more is, this is for your entrance exams, enolate mode. Okay, now in enol mode, I'll just write the things. Suppose if you're taking a ketone, right, let us take a ketone like R COCH3, one ketone. Here also same thing. I like the this one, COCH3. Here, when you do enol mode, this one, suppose if I do it in the form means in the presence of a catalytic H plus, means acidic medium H plus. Here if I do, means here I do it in the presence of a base. Yeah, inverted commas. This is, yeah, dotted lines, I'm sorry. Right. So here first thing which you get is, from the ketone you are going to get enol. Here from the enolate mode you will be getting enolate. That's done. Reverse action. Then here it's going to react, this enol is going to react in protonated form. Then you will be getting a compound called aldol addition product. What you will get? Aldol addition product. Okay, done. This one further, when you dehydrate, what product do I get? Aldol. This is addition product. This is aldol condensation product. Aldol condensation product. Okay, students, done? Understood? That is addition product. This is condensation product. Here, enolate when I take. Right? So here further, in the presence of COR dash, there also you will be getting aldol addition product only. And here also same thing, you will be getting aldol addition product. Aldol addition product. This is understood, students? Clear? Right. Now further, in aldol condensation also you have different varieties, means when I have to write the mechanisms. Here in aldol condensation, basically you can study the mechanism under base catalyzed aldol reaction. This is one method. You can also, means after this aldol base catalyzed aldol reaction, then base catalyzed dehydration, because both the steps will follow, isn't it? As I told you, after aldol product is formed, then you're supposed to do the dehydration. So here after this you will also have base catalyzed dehydration. Base catalyzed dehydration reaction. Right. One more we can also do, that is acid catalyzed aldol reaction. This is one, and the next would be, as I told you, acid catalyzed dehydration. This is done, students. This is understood. Yes, both the final product is alpha beta unsaturated aldehyde, or that is what we said, aldehyde alpha beta in unsaturated compound we said. So now for your grade 12th, so basically for your entrance exams or competitive exams you need to know the complete concept, but for grade 12 you can do this. But further for your mechanisms, for your competitive exams, you need to do all these methods. Right. Now for your grade 12 students, I'll be showing you this concept so that it is easy for you to remember and write the product in the exam. Let us see that. Now what did I say? I said for first we are going to take an aldehyde. Compulsory thing is they should have alpha hydrogen. Now let me take an aldehyde. So first thing, let me use this pen. Let us write mechanism. Right. So first I need an aldehyde. I'm going to take CH3, CH2. Why did I take this aldehyde? Because you have alpha hydrogen. This is your alpha hydrogen. Adjacent to the functional group is called alpha hydrogen. The hydrogen adjacent to the functional group is called alpha hydrogen. Done. I'm going to take one more, that is CH3C. One hydrogen I'm placing here above and below, no problem, isn't it? Yes, same thing. Both are aldehydes. Which is alpha hydrogen? This is alpha hydrogen here. Here I'm going to take, means in the presence of a dilute alkali, right? I'm going to take dilute alkali. Done, students? Yes. So when you do this, the first important thing, just see here, first this shift of double bond. When the double bond shifts here, this becomes minus, correct? Now, the hydrogen from here means the alpha hydrogen from here comes and attacks this oxygen. I'm doing it in a simpler way, not in detail as I told you. For the competitive exams, there's a different level of understanding. So I'm just writing for the CBSE board, OH and this compound. Now this H is still here only. Done. Next one. What are we left with? This carbon is here. Yes, students. So how many hydrogens? This is already shifted and you have one hydrogen. And the CHO is here only, and this CH3 shifts down. Now let us count the number of hydrogens. 1, 2, 3, 4 bonds. Done. Number of bonds around carbon. Now see here. What are you observing here? First, the shift of hydrogen. Remember that. So here you have both an alcoholic group and an aldehyde group. That's why this product is called aldol. Done, students. Now what you're going to do, you're going to take this aldol product. Still the process is not complete. We need to dehydrate it, isn't it? Now you're going to warm this, heat it, then water or dehydration process starts off. Done. So during this dehydration process, yeah, what are we going to take? We are going to take out water. How we are going to take out? From where we are going to take out? Just see, simple. Yeah. So, see, students. OH here. Yes, students. OH here, H here. Adjacent, whichever carbon has shifted, from whichever carbon hydrogen has shifted, OH from here, H from here is eliminated. Now then what happens? This bond drops in here. What do we get? Now copy. CH3. Next this is CH2. So what did I do? I have shifted hydrogen from here to this oxygen. So OH, the same carbon, this hydrogen I'm going to remove as water. CH. Then what happens? This forms as C double bond C. Okay. Now one hydrogen is still here. Next one. This CH3 is here because this hydrogen is lost, isn't it? This is lost. This is also lost. Now what is left out? CHO. What is the name of this compound? This is nothing but alpha beta. Okay, why? Alpha beta. This is alpha, this is beta. Between alpha and beta there is an unsaturation, isn't it? Alpha beta. So unsaturation. So alpha beta unsaturated compound. Unsaturated compound. Simple, isn't it, students? Done. This is your aldol condensation mechanism. So remember, you need to take aldehydes which has alpha hydrogen, introduce on the presence of a dilute alkali, as that is base catalyzed reaction. After that you are going to take means it will go to the next step, that is dehydration, where water molecule is removed from the same carbon, means carbon where H has shifted, that hydrogen is OH, and finally double bond is formed, giving an unsaturation this compound. So thank you for watching aldol condensation. I'll get back to you again with carbylamine reaction, then we'll be doing Gabriel phthalate synthesis. Thank you for watching, students. Welcome, students, to one more session of your organic toolbox. Right. So in the previous video, what did I teach? Basically, I've taught you about the aldol condensation mechanism. Now, in this particular video, let me teach you what is the mechanism for carbylamine reaction. Okay. Yes. Along with this, I'll also be teaching you one more mechanism, very interesting, that is Gabriel phthalate synthesis or Gabriel phthalate mechanism. So here, when I started with the organic toolbox, I have bifurcated into 3 different toolbox sections. Then I started giving you the examples also. Now I'm following the same pattern. Do watch both the earlier videos and then come back to this. Right. So when I speak about carbylamine reaction, this is quite common name reaction in organic for your grade 12 CBSE, even for the entrance exam also. So be careful, students. Try to understand, concentrate. I'll be clearing everything. Right. So basically, in carbylamine, as the name suggests, see here, amine. That means here you're going to get, or you're going to form a the basic product or the formation can be done only by using an amine. Okay, and so in the carbylamine reaction, first important thing is you will be taking a primary amine. Okay, so the first basic requirement, let me write that. In carbylamine reaction, I'll show you the mechanism also. Very easily I'll teach. So primary amine I'm going to take. So here this primary amine can be what? It can be both aliphatic primary amine, and it can also be aromatic primary amine. Okay, aliphatic or aromatic. So this is capital A, this is also capital A, aromatic. So it can be aliphatic as a straight chain or in the form of a ring structure like benzene. So I'm going to take this primary amine. What am I going to do? I'm going to take this primary amine and I'm going to warm it. Right, so I'll be writing it as warm. With what am I warming it? I'm going to warm it with chloroform. What is the formula for chloroform? Chloroform is CHCl3. We will see what is chloroform doing, or what is iodoform doing. Everything will be doing it, right? So I'll be taking chloroform. I mean, I'll be warming this primary aliphatic amine with the chloroform. Along with that, I'll also be here chloroform you can use, or alcoholic KOH also you can use. So it can be warmed with both. So I'm writing alcoholic KOH also. Done, students? So basic requirement when we write in the reaction, we'll be writing these two. So this is chloroform, you should remember, alcoholic KOH both. So primary amine, chloroform, alcoholic KOH. Now, so what it forms? It's going to form a compound called isocyanide. Let me change the sketch pen. It's going to form a compound called isocyanide. Right. So other name for this is called carbylamine. Carbylamine, as in name reaction suggests, see here, carbylamine. Yes, what is the speciality of this? This has very offensive smell. Carbylamines have very offensive smell. You can get it in a paragraph based question also. Compound A with offensive smell. If they start like that, it is nothing but carbylamine compound. Right. So offensive smell is formed. Now along with that there's also release of KCl in water. So this is a basic reaction. Remember, primary amine, chloroform, alcoholic KOH, isocyanide formation. Now let us write the reaction, then go with the mechanism. Right. So I'll be taking both aliphatic and aromatic, both examples, and I'll do it. Right. So first one, when I take an aliphatic amine, so let me write it as aliphatic amine here. Then I will write one more reaction here, the second one as aromatic amine. Aromatic amine. So both, it's easy for you to understand. So when you take aliphatic amine, when you take aromatic amine, let's see. So aliphatic amine is nothing but straight chain. So for this, I'm going to take an example of CH3CH2NH2. What is this name of this compound? This is called ethylamine, isn't it? Why ethylamine? Because 1, 2. Eth means 2 carbon atoms. NH2 is nothing but amine group. So I'm going to take an ethylamine, the basic amine, that is the basic aliphatic amine, right? So, and after that, what did I say? We have to add to this chloroform. So I'll be warming this with chloroform. I'll also be adding KOH, right? Done. So same, let me draw one line in between these two so that it's not confusing you all. Right. So here I'm going to take aromatic amine. So aromatic amine, what am I going to take? I'm going to take a compound with amine group. Amine is nothing but NH2. What is the name of this compound? This is nothing but aniline. Now same thing, I'll be adding CHCl3 and KOH. Right. Now important thing is here, I'll be adding, or let me take first the moles also. I'll tell you, remember. So 3 moles of KOH. I'll show you the mechanism, you'll understand. Remember as of now. Here in both the things, the product is, just see, if you're taking aliphatic amine, CH3CH2, right? NH2 is here, right? So remember, I'll let me move my page a little bit above, students, so that it is easy for you all to see the last part also, right? So when you're taking aliphatic amine, just like this, CH3, CH2, NH2, right? So exactly take this part, exact part, this one here, and here you will be taking this ring. Okay, now copy the same down. I'll show you the mechanism for in just 5 to 3 seconds. 2 to 3 minutes. CH2, CH3, CH2. Then you're going to write NC and KCl water. Okay. Then here I'll be copying the same thing. We will see how it has come. Benzene ring, same like this. N triple bond C. Okay, NC, right? Then 3 KCl plus 3H2. Okay, why did I write 3 here also, here also? Now it is confusing. Well, how, ma'am, how can I remember this? Let's see. So let us write the name of this compound. This is called, the name of this compound is called ethyl isocyanide and the name of this compound is nothing but phenyl isocyanide. Now do remember this whole confusion. Let's see the mechanism. Simple. Let me take this compound and show you the mechanism easy way. What is it? Basically I'm going to first take aniline. Okay, so same is the case with primary aliphatic amine also. Now you take your aniline. So here I'm going to write it C6H5. Okay, NH2, right? Aniline. So N, divide this H here and H. Done. What did we take? Now chloroform CHCl3 we have taken, correct? And KOH also. So here what I'm going to do, I'm going to show you with CHI3. Just see here. C. Earlier it was CHCl3, isn't it? Now I'm going to show it with CHI3. I'm going to take I and I'm going to take I here. Done, students. And you're going to write how many moles of KOH as I told you? You're going to take 3 moles. So write KOH like this. KOH. KOH. Done. Right. Now this is all over. We are going to warm it. Now the first step is exactly the C6H5 is here. Okay, C6H5 is like that only. Now see here. First important thing, we will take out water. When you warm, the water comes out, isn't it? Just so let us take 1H, 2H, 3 and 3OH. So how many? 1, 2, 3, 1, 2, 3. So let us take out and write as 3H2O. That is the reason I have written 3H2O in earlier reaction. Done, students. Now what is left out? We are left with K. Now 1, 2, 3 and 1, 2, 3 potassium. So how many are there? 3 Ki are there. Over. What is left now? C6H5. Now water has come out because you have warmed it. That is done. Then Ki, potassium iodide, 3 moles are out. What is left out? C6H5 is left. Here this N is left. Here this C is left. That's it. What is the name of this compound? This is nothing but phenyl isocyanide. Right? So what is the other name given to this? This is called phenyl carbylamine reaction. Carbylamine. So that is the reason this is called carbylamine reaction. Done, students. So very interesting, isn't it? Simple thing you have to remember whenever you're doing carbylamine reaction. Simple. Primary amine you require, that is aliphatic or aromatic, which I have written here. Then you require chloroform. Then you require KOH also. Alcoholic KOH. Then as I told you, you will get a product called ethyl isocyanide if you take aliphatic amine. You will get a product phenyl isocyanide if you take an aromatic amine. Along with that, there is release of potassium chloride and water. As I showed you how to remember this, I showed you in the back page. Please take that. I took that is aniline. I have taken CHI3 instead of Cl. If it is CHCl3 chloroform, here it will be Cl, nothing, right? Then KOH, you warmed it. Immediately when you warm, take out 1, 2, 3 hydrogens, OH, 3 water. So it becomes 3 water molecules. That's released. The left, next is the leftover potassium iodide. How many? 3. The leftover is C6H5, N and C, that is phenyl isocyanide. So it's interesting, isn't it? So whenever you are learning a reaction, try to learn it in a proper way. So when you learn it in the proper way, you will never forget it, students. So thank you for watching. Let me come back and teach you one more name reaction. That is your, as I told you earlier, Gabriel phthalimide synthesis. Thank you, students.